Hi there. Super excited today to be moving into antiderivatives. If you are just coming to this video, then you probably were doing a lot of derivative rules and a lot of derivative applications before now. And now it's time to take a look and go backwards. So let's jump in with polynomial type of functions to begin with, because I think this is probably where we're going to see the most intuitive approach. So if you had to explain to someone how to find the derivative of a polynomial, what would you say to them? Would you tell them about the power rule? I probably would. I would say, hey, take the power and move it in front, right? Because I'm just not going to use math terms right there, right? Take the power, move it in front. So let's see, the derivative of x to the n, we would move the power in front. So we'd move the n in front, and then you would decrease the power by 1, right? So in finding the antiderivative, you're going to do the opposite of each one of those steps and in the reverse order. So in order to find the antiderivative, and I'm going to use just a symbol here, to find the antiderivative, you're going to increase the power by 1. And you're going to divide by that power. So it's the opposite. So instead of decreasing the power by 1, moving the number in front and multiplying, decreasing the power by 1, this time we're going to increase the power by 1 and divide by that power. So we use this notation, this integral notation, to denote the antiderivative. So when you're finding the antiderivative, you're looking for the function who has this first derivative. You're really asking yourself, if this is the derivative, what was the function? So if we have f prime or f double prime, we should be able to find f. However, we could run into some problems. Let's see what kind of problems we run into. So we're going to find the antiderivatives of the ones in the boxes here. So we're going to do them term by term. So I'm going to take the antiderivative of 3x squared, meaning whose derivative is 3x squared? Well, that would have to be x cubed. Whose derivative is 2x? That would have to be x squared. Whose derivative is 3? That would have to be 3x. And then we use a plus c. Now, this c is called the constant of integration. And we don't know what c is. All I know is if I take the derivative of c, I'm going to get 0. So it's not ever going to show up in my derivative, but I have to consider that it could have been there. Now, sometimes when we look at taking the antiderivative, we have to do a little simplifying before we can take the antiderivative. Let me show you what I mean. For this one, I probably would split that up. So that it becomes a little easier to take the antiderivative. So really, I'm looking for the antiderivative of x squared plus 2 minus, and I'm going to rewrite this as 4 times x to the negative 1. Now, let's take the antiderivative, okay? So the antiderivative of x squared, we're going to increase the power by 1, so that makes it x cubed, and we're going to put it over that new power. Plus the antiderivative of 2, we'll ask yourself, whose function is 2? That would be 2x. Now the negative powers get fun. Okay, so I've got minus 4. We're going to increase the power by 1. Uh-oh. If I increase the power by 1, I get x to the 0. Okay, friends, look at it back like this. Whose derivative is 1 over x? I hope you're thinking ln of x, and you would be right. That is an exception. If we have 1 over x and we're looking for the antiderivative, we do not do the power rule because we get x to the 0, which would be 1. So instead, we have to use our ln of x. All right, so I'm going to write this so I have a little bit more. Oops, and I forgot an x there. I have a little bit more room, and it's got a plus c. Don't forget your plus c. All right, look at this one. I've got to do, again, some simplifying before I can take the antiderivative. So I'm going to FOIL that, right? 2x squared plus 4x. And then I've got, what did I do? Oh, minus 3x. Sorry, had to think for a moment. So I've really got, I'm looking for the antiderivative of 2x squared plus x minus 6. Now let's do the antiderivative. I've got a 2. I'm going to increase the power by 1. That makes it x to the third over that power. Plus, now remember this is x to the first, so I'm increasing the power by 1, putting it over to the new power, and then minus 6x plus c. Don't forget the plus c. All right, so far so good. These are good working out that power rule with antiderivatives. Now, on the last one here, I would rewrite this as 2x to the negative 1/2 before I take the derivative. Watch the exponents, okay? So we're going to increase the power by 1. So negative 1/2 plus 1 is going to give me a positive 1/2. And then I got to put it over that new power. Now think about it. When we divide by fractions, we flip the second one and multiply. So dividing by 1/2 is really the same thing as multiplying by 2 over 1. So I get 4 times the square root of x plus c as my antiderivative here. Okay, let that one sink in a little bit because every time we deal with the rational exponents, we have to deal with this whole adding one and then simplifying with fractions there. All right, now let's start looking at some of the derivatives that we learned. We learned that the derivative of sine is cosine. The derivative of cosine is negative sine. So if we want to have their antiderivatives, the antiderivative of cosine, that'd be the function whose derivative is cosine, would be sine. And the antiderivative of sine would be negative cosine. The signs are backwards. So this becomes another one you want to add to your wheelhouse, i.e. memorize. All right. So let's see. We're going to find the antiderivative of 2 sine. Well, the antiderivative of 2 sine would be 2 times negative cosine, which would be negative 2 cosine, plus the antiderivative of cosine, which is sine. And don't forget the plus c. All right, let's combine that with a power rule here. So we're doing the antiderivative of t squared. We're going to increase the power by 1, put it over the new power, and then I'm going to do minus the antiderivative of sine. The antiderivative of sine is negative cosine. Well, I already have a minus there, so I'm going to make it a plus cosine. Think of, oops, and I should use a t there. Think about minus a negative cosine is really what we did there. So I wrote it as a plus. All right, let's look at this one. I want the antiderivative of 4x. So I've got 4x. I'm going to increase the power by 1. The power is understood to be 1, so it's going to increase to make it 2, over the new power minus 3. Now I need the antiderivative of cosine, which is sine. And I'll just clean that up to give me 2x squared minus 3 sine of x plus c. Okay, let's look then at the antiderivative of x to the 1/2. That's how I want you to think of the square root of x. So we're going to increase that power by 1. So 1/2 plus 1 becomes 1.5, which is 3/2. Divide by that new power. Plus, and then antiderivative of sine is negative cosine. Okay, now remember, dividing by 3/2 is going to be the same as flipping it and multiplying. So that becomes 2/3 x to the 3/2. I'll write this as minus cosine x plus c there. All right, good work with those trig ones. Really focus on memorizing those. Those are going to really help you once you have them memorized and you can just rattle them off. Okay, now our next section is really going to focus on that plus c. So I want to show you, we have information about second derivative, we have information about the first derivative, we have information about the function. So let me show you how we use that. So we're told that the second derivative with respect to x is 2. So if I ask you for the first derivative, we're doing the antiderivative. So what would the derivative have been if the second derivative were 2? Well, it would have had to have been 2x plus some number. Think about it. If I take the derivative of this, I get 2. Derivative of c, I get 0. So it works. Now, we are told f prime of 2 is 5. So f prime of 2, so it means when x is 2, we know f prime is 5. So what did c have to be? C had to be 1. All right. Now I know what f prime is, not in general, but exact. Now I'm ready to go to the function. Okay. So if this is the derivative, what was the function? Well, again, we take the antiderivative. What was the function if the derivative was 2x? It had to be x squared. Plus, if the derivative was 1, the function had to be x and then plus c. Now, again, we were told f of 2 was 10. So that means when x is 2, the function is 10. So what did c have to be? C in this function had to be 4. So my function had to be x squared plus x plus 4. And we get that from here. That's what we were looking for. Okay, let's do it again. A little bit more difficult function. Okay, or second derivative, I should say. All right, if this is the second derivative, then to go to the first derivative, I'm going to have to increase that power. So negative 3/2 plus 1. So negative 1.5 plus 1 would be negative 1/2 plus c. Okay, now we are told that f prime of 4 is 2. So f prime of 4, so when x is 4, I'm going to write this as 1 over the square root of 4 because that's what x to the negative 1/2 means. So that means this is 2 equals 1/2 plus c. So c had to be 1.5 or 3/2. Okay, so that means that f prime of x is x to the negative 1/2 plus 3/2. Okay, remember we're coming from here to get that. Now let's do it one more time to get the function. We'll increase the power by 1. So x to the negative 1/2. Negative 1/2 plus 1 gives me 1/2 plus 3/2 times x plus c. And again, we're told f of 0 is 0. So nice for us. So we'll put in 0. 0 to the 1/2 plus 3/2 times 0 plus c. So c had to be 0. That was really nice for us. So our function ends up being x to the 1/2 plus 3/2 x. And again, we get that from here. So in order to figure out what c is, I have to be given what's called an initial value. We have to be told a value of a point. We can then plug it in. We can solve for c to determine what the value of c should be. All right, how are we doing with those antiderivatives so far? Holding your own with it? Good. All right, let's take a look then at a word problem. All right, an evergreen nursery usually sells a certain shrub after 6 years of growth and shaping. Here is the growth rate. The seedlings are 12 centimeters tall when they are planted. T equals 0. That's important. That is telling us that when t is 0, h is 12. All right, A says, find the value of the differential equation when t is 3, and then explain what that means with units. Okay, so it's saying when t is 3, what is dH dt? So I'm just going to plug in 3 for t. 1.5 times 3 is 4.5 plus 5 is 9.5. And let's see, h is in height, t is in years, so this is in centimeters per year. And then we're asked to explain what this value represents. So that means when the derivative is positive, the height is increasing at a rate of 9.5 centimeters per year at t equals 3 years. Remember, we've talked a little bit about making sure all of those little phrases are there because you're going to need them. Okay. B says, now find the equation for h of t. Then determine how tall the shrubs are when they are sold. Okay. So we need to find the antiderivative. So if we do the antiderivative, we're going to increase the power by 1. So it becomes t squared over 2 plus 5t plus c. Okay, so this is 3/2 divided by 2 makes 3/4. And now we're looking for C. Okay, that's why we were told when t is 0, h is 12. So let's put in 0. By the way, if you get it if they give you a value when t is 0, they're being really nice to you because 0, 0, c is 12. All right, so h of t is 3/4 t squared plus 5t plus 12. And now it's asking us, how tall are the trees when they are sold? So go back to your prompt. You were told that they like to sell them after 6 years of growing. So we're trying to find h of 6. So we'll plug in 6 here. So 6 squared, 36, divided by 4, 9 times 3 is 27, plus 30, plus 12. So h of 6 is 57 plus 12 is 69 centimeters. All right, now you can see we've done some problems like A before. Now we're going to add the part like B where we find the antiderivative. Let's do a particle motion question now. We're being told the velocity is 1 over t, square root of t. Time t equals 1. The position is 4. So we're told p of 1 equals 4. We're asked first for the acceleration. So if you have velocity and you're going acceleration, that's derivative. So we're told the velocity is t to the negative 1/2. So if we do the derivative, we're going to get negative 1/2 t to the negative 3/2. Remember, take the power, bring it in front, decrease the power by 1. Don't forget your derivative rules just because we're doing antiderivatives. Then we're going to plug in 9. Now, I'm going to rewrite this as t to the positive 3/2 first. And then think about what 3/2 power means. That really means the square root of t, then cubed. Square root of t, because of the 2 on the bottom, and then cubed. So now we'll put in 9. I've got negative 1 over 2, square root of 9, then cubed. Okay, square root of 9 is 3, cubed is 27. 27 times 2 is 54. So I've got negative 1 over 54 for my acceleration at 9. Okay, last one then, what's the position? Okay, so this time we're going antiderivative. So the antiderivative, that's where we increase the power by 1. So negative 1/2 plus 1 would be 1/2, and we put it over the new power. Don't forget plus c. So this p of t becomes 2 times the square root of t plus c. And we've got to find c because remember, we were told a point. So when t is 1, we know the position is 4. So what does c have to be? C has to be 2. Okay, so we know the position equation now is 2 square root of t plus 2. But we're being asked for what is the position at t equals 9. So we want the position at 9. So square root of 9 is 3, times 2 is 6, plus 2 is 8. And friends, that is how you're going to see it most of the time on AP. You're going to have the velocity given to you. You're going to be asked to do the acceleration. Then you're going to be asked to do the position. So you're going back and forth between derivative and antiderivative. So I hope this has helped to kind of get your feet wet with antiderivatives. As always, if you have questions, please leave them in the comments below. I would love the opportunity to help in any way that I can. Bye for now.